the conference IEEE DESSERT'. It's my pleasure to invite you for our plenary session number 5. Previous 2 days were very interesting, very resultative, because we had possibility to hear about 50 reports. Today we will finish after this plenary session and two topical session. During this plenary session, we will hear two very interesting talk. It is more industrial talk, more practical talk, and it's my pleasure to invite for first plenary presentation our colleague, friend, Dr. Mario Fusani. He is a research associate with the Information Science and Technology Institute of Council of National Research in Pisa, Italy. Mario has been working since 1973 in this institute. In 1986, he founded the System and Software Evaluation Center in the same institute, Active Science then. He has been working in various international working groups for standardization. He is one of the most famous specialists in European area requirement engineering, standardization, and so on. I'm happy that we performed 4 joint projects with Mario and his institute. His current research interest is in software-intensive system safety assurance and in safety-related standard comparison and evaluation. I would like to invite Dr. Mario Fusani for his presentation. Welcome, Mario. Please.
Thank you. Thank you very much. And I'm very pleased to participate in this issue of this DESSERT conference. Thank you very much, the chairs and the organizers who succeeded in this very task in this very difficult time. And I'm going to speak. Let me just turn on. Okay.
Please.
Just a moment. I'm sharing the. Yeah. Okay. Okay, there's a moment.
Please click Start Sharing and select entire screen.
Yes.
And then confirm that.
Can you see the screen now?
Yes.
Oh, okay.
Absolutely okay. Welcome, Mario.
Okay, thank you very much. And this talk is going to be on quality of standards. And this is a topic I'm carrying on for years, not continuously, but from time to time at the Institute of Information Science of the National Research Council of Italy in Pisa. And I'm going to talk about quality of standards and how you measure quality and why quality is important. And then I will speak of means to measure quality and the purpose for doing all this, and also introduce a more updated mean to measure quality and to understand how not just the standard but the quality on the way standards are made. Okay, let's start with why in my opinion and in opinion of other researchers, quality of standards is important because standards are a common reference for doing for building products and processes able to build the products. And so the quality of the standard is reflecting, is having an impact on those products. And when products are safety related, systems, equipment, that is very important. And they have impact on our daily life, a very strong impact. So quality, by this property, qualities of standards has got an impact on our daily life. If perhaps people do not realize this, but this is my opinion. And who is interested in this? Okay, you say how very few people can be interested in this because why quality of standards? There are guides. There are standard worldwide organizations like ISO, IEEE, and SANELEC and others. They issue guides for making standards, guides to be used by the international working group that makes standards. But those guides are related mostly with the way how to structure the standard. They also say how to wording a phrase, how to paragraph, and so on and so forth, but are not very quality. And this fact of some lack of quality of standard was addressed also by scientists during the years. One important paper was many years ago of Norman Fenton, professor at the City University in London. He published a transaction software engineer entitled "A Strategy for Improving Safety Engineering Standard." That means this improvement means that it was understood that there should, at that time, something should be done to improve those standards. But this practically this situation is still carried on up to the present because very little effort has been done. There has been this problem has been addressed also by a group of experts working in avionics standards. They made a workshop in 2014 about that to assess the efficacy of standard. That was a very important one. And there was also NASA in there interested in safety of the space vehicles. And the results was, well, okay, we should do something, but it was not clear how to do, what to do. And the NASA published a report in 2015 about the same thing. So, as I said, not very many progresses were made by that time and after that time. So, but recently, conveners of international expert working groups expressed the willing to express to our institute, the willing to try to have rules, methods, and possibly tools to assist standard developers. And they were interested in the history of a research carried out at our institute in Pisa, National Research Council, starting back from 95, when this research line is related to study the natural language aspect of requirements. Requirements are mostly expressed at the first time. Requirement is pop to your mind is expressed in natural language. Then this transformed in formulas, in more formal expressions. But at the very beginning, and this is the point, the very beginning is expressed in natural language. And there was, I'm not going to detail, but during the years, this problem, this research line has produced a couple, 2 or 3 tools to analyze and possibly to improve the natural language expression of requirement, mostly software requirements, but requirement in general. But when the DESSERT conference started for me in 2009, I started to put this the attention of this research to special requirements, requirements that are in the standards. Requirements of standards are called clauses, and especially with shall type clauses. What people must do to so that the equipment and the processes expressed in the standard are conformant to the standard. And very recently, I'm trying to collect with the help of conveners from IEEE and Senelec a literary corpus to analyze with a more modern methods the standards in order to discover how this can be, how this goal can be achieved. That means improving the standard, but in what aspect? So what is the quality standard I'm speaking about? Well, sorry, we have to turn our attention to quality models. That quality is a set of attributes of features. Anything has to reach its purpose, and so applying some quality model engineering. I'm not going to details about this. To standard, we can say, for instance, who are the users? Users are developers of products and processes, but also the assessors, but also standards developers themselves, because a standard gets improved once in a few years. And so the qualities coming up from the model are, and also in the first paper by scientists in the late 90s, the problem of ambiguity was raised, and also the problem to easy understandable and to application to the projects for developer, and also the problem of easy understanding of standards by the assessors. And there are some different aspects of those, but I'm not going into this way. I'm going to speak about the way to measure this quality in this talk. And there is also the problem of how to get the standard up to date with the state of art, and in the same time to be a reference, a stable reference. So there is a trade-off in this, and also the trade-off of the standard about having requirements which are not dealing with the way to implement, but should address also the techniques. Say this techniques is better than that, and this is another trade-off. But back to the problem of ambiguity, of trying to get to understand the point of the aspect of the standard related to the easiness to be understood. In the year, at our institute some quality model for standard for requirements, and which I try to apply also to standards. Pointed out some aspects of the text of the language, natural language, used to express the requirement, and some characteristics were pointed out. This is a partial list of those. We have implicity, that is when we express, if needed, optionality, the option of people, or subjectivity, what is simple, what means known, and vagueness, what means for vagueness, what means easy, what means edit. But these words happen in the standard, and I can show it in a moment, and so on, and other aspects. But I'm not. This talk is not addressed to this aspect, but use this model in order to explain a way. I'm trying recently to use to understand the way, the quality of the way a standard is made. For measuring the requirement at my institute, it was developed a tool called Quartz, quality analyze requirement specification. And this is the user interface, but just to tell that we can with this button, we can choose the characteristics to be analyzed. We put a file, some file of text of the standard in a section of the user interface, and we select which aspect to analyze, and then we get a report. These are a scrolling window, so we can use tens of thousand sentences in for analyze and for the requirement. We will also just to tell you, try to adapt this this tool to analyze is some project containing million of requirement, but this is another story, but still related to the quality. So we use this tool. We have used the tool in the many years ago to analyze some popular safety-related standard. Like this is a for nuclear power plants, for avionics. This is for railways. This is a very, very popular standard, and for general safety-related safety-related products and processes. This particularly about software, but this was the results. All the aspects, vagueness, multiplicity. Okay. There are many of those. I have to say that some of these are false positive, and so a manual inspection is still needed to eliminate the false positive. But the report usually are interesting, and the conveners of standard just agreed that this could be a way to better understand the standard quality. And but the point is, from last year to now, I try to look where the problems of the quality in standard is starting. It started at the very beginning. The standard is written, starting with the first draft, because those are the final draft analysis. But I think it would be important to look at the first versions of the standard when people is discussing, and And then it is possible to intervene to improve the standard, to improve the quality of the expressions in order to have a final version more acceptable, more understandable, and with less ambiguity as possible. And also, besides the draft of the standard, we have in the beginning, during the process of making the standard, we have many comments from experts worldwide, because a draft is circulated in all the universities, in companies, and all the environments that are interested in using the standard to develop projects. And so we get for each standard thousands of comments. The comments refer, this is an example of a line of a comment sheet to analyze a standard related to railway. And in the comment there, the clauses are identified, and then there is a kind of comment, general, technical, editorial, and comments. The comments say what is not acceptable from the point of view of the expert, and some changes are proposed. And this is important so both the comments and the draft text of the standard are data. There are data on which we can perform our analysis. We need to do it automatically, of course. We need engines to extract the clauses from the standard. Usually they are PDF or Word documents, and put this information, this data, in a way it can be analyzed by a tool. In this case, we are using our Quartz tool. And also we get also the comments, we extract the comments and try to use the comments as data. This I'm going to show an example of an analysis of a standard, of the draft standard. This is a railway-oriented standard, 5128. For the final issue was made in 2011, but I'm using the 2009 draft in order to perform, and the comments of experts in order to perform this analysis I'm going to show. Okay, this is what we get from the first part of the analysis. We are going to, this is a data frame, actually, consisting of clauses identification. In this case, I have, for this draft of this standard, we had 261 lines. And these are the qualities of, I pointed out before, detected by a tool, let's say non-quality, the possible defect of quality. It's vagueness, subjectivity, multiplicity, optionality, weakness, word and sentences, which are such problems. Okay, it is a very sparse matrix, but you see the multiplicity, and the tools point out in 261 clauses an interesting bunch of possible defects. And this is an example. This is a portion. This is a portion of the output of the tool. In the horizontal line are all the clauses. You think of 261 clauses in this example, and these are the, well, or the cardinality or the frequency, depending on the way we want to process all those data, of each possible defect. And still we have this defect list. And this is what happens in all the clauses of the standard. And so these are data we are using for our analysis, and we want to compare this data coming from the tool analysis, data coming from the expert judgment. So we are going to extract, this is an example. I have a list of words that indicate the expert is not accepting each clause he is examining, and in the text they are words like this: cannot, wrong, change, misunderstood, and don't. There are sort of 100 of these words, and so we can have a metric to extract data, processable data from this, and measure the number of words in each comment, or the density of word in each comment. And so we get a more complete data frame, which we have here. The clauses of the standard, clause identification are here, and still in this example 261 lines. We have the results of the tool analysis, and we also have the information taken from the expert judgment. And so we can set this data frame as a data set for using machine learning algorithms. This is the process. So we have the source of data, which are documents, PDF or Word documents of the draft standard. Here we have sheets with the lines, with the comments of the experts. And I said we process this. I got a data frame with some engines that extract the clauses and they put in a structured way. And this, the same, we have an engine which extracts the words and the frequency of the words that are indicating that each clause is accepted or not accepted. So we have this data frame I showed before. And, sorry, what we can do here is to consider these scores or expert judgment normalized in the way I said as label of feature, where the feature are the results of the quality analysis made by tools. And as frequency, we have this frequency, and we can, for each clause, we can ask, is there any relationship between what the tool found and what the experts found in each clause of the standard? So we can consider this a data set labeled, where the labels are the decision of the experts on each clause, and the feature are what is coming from the analysis of using the tool. And we can to check if there is any relationship between those, of which kind of relationship. We can train this data set with several possible algorithms of machine learning. When we train this, and any algorithm is creating a model in such a way if we feed with new draft analyzed by the tool with the score of the analysis and new comments coming from the expert, we can feed that in the model and try to predict if the relationship holds. The relationship we think we have found with this during the training phase is hold. If it's hold, we can, so with the comparison of this, we can do correlations of other comparison. And if this holds, we can use this. We can use it, and the standard maker can use this. I will get to this shortly. So, as I said, we can call the expert judgment as a label, and this is a data frame coming from the tool analysis, and so we can do an experiment here. So we can consider since I didn't have a new standard to shortly to analyze it, so I did what usually is done with this. We divide in two parts this our data set. This is 60%, this is 40%. 60% we use this for training algorithm, and this is for testing the results of the training. This is tests, so this is the data, training set, and this is the test set. Here we have 150 lines. Here we have 100 lines. So this is not very big. It's very small from the machine learning using point of view, but I am sure this is an experiment as a demonstrator. So we have the labels for the training set, and the label for the testing set. And the question is there a relationship between this matrix and this column, which can tested in the testing part? So if we apply the algorithm here, we predict something, we will be comparing with this. So if X is giving Y, X1 is giving something to compare with this. Okay, these are always labels provided by the expert. This is the expression using on the training set an algorithm. This is actually it's a classifier algorithm. This is a classifier used for classification, but I could have used it also linear regression algorithm. But this is proven to work with the mock-up data, and this is our real data. So we get these results, and this is the prediction, and this getting from applying the algorithm. This is in this we train the data as those data with these results, and here we predict in the test set, using the test set, we predict the output, and this is the output. We compare this with that. This is done by the algorithm. This is done by these are the expert score. So this is the real judgment, and this is the a forecast of the judgment on the same data. So we can do a comparison, but I have to say this is the way to do a comparison. But in this case, I'm not believing that this is very meaningful, because we have very few data and we have a sparse matrix. As you see here, the lines have been shuffled. They are not in sequence, shuffling here and there. But when we shuffle, if the matrix is very sparse, we can get different results. And if you try again, I can find a slightly different correlation for it. This is sort of a correlation, but I do not believe in this correlation now with this very, very small sample. This is just for showing the how we want to do the job. So conclusion, I wouldn't say this conclusion because it's a work started a month ago, less than a month ago. So I collect data and I put together and trying to use the machine learning algorithm, very simple machine learning algorithm, and then basically they are linear regression algorithm for now, and we can progress in where the job is going on, the line of research is going on. We can try to collect more comments, and the convener promised me to have more drafts, which we analyzed up to have up to several thousand of comments. And in this case, we can check again, trying to change algorithm, try to better the quality analyzer, to do some sensitivity work and extend the quality model with the new words and so on. And we also can try to partition the comments between, but this is we are looking mostly to the influence of editorial, but we have some ideas about technicals and use a better tool. And in the end, we try to skip the quality analysis and to check directly from clauses to expert comment, if to check if there are some not evident hidden relationships with the way the clause is done and the comment by the experts. So this is what we are going to do in the next years. And this experiment is just started. So this is just what I showed is just a hint of how the thing can be done, but we'll change. We'll try to improve the process as well. Okay, this is end my presentation. I hope you didn't have problems with that. And if you have questions about.
Thank you very much, Dr. Mario Fusanis. Thank you very much, Mario. Now we have time for questions and answers, for discussion. This is very interesting topic, very important topic, I think. Any questions, please? Okay, maybe I'll start. Mario, I have two questions. First one, related to artificial intelligence area, AI,
yeah,
as model, as algorithm, as AI-based systems. We, during last year, analyzed standards, not formally standards, it's regulatory, different regulatory documents related to requirements to AI,
yeah,
and AI systems. It concerned NIST, IEEE, UNESCO, and other high-level documents. And we saw that there are a lot of contradictory in not only requirements, in hierarchy.
yeah,
Hierarchy of characteristics. I think it is the main question in context of quality standards assessment is the right hierarchy. What about possibility assessment these issues for assessment of standard, correct standards hierarchy? Thank you.
Okay, thank you for the question. This is this is a very nice, a very good question, and it's a very important problem. But this is a step forward about our research, because the topic I was speaking about is related to locally to each local clause. So possibly problems internally to a clause and to one requirement, and possibly some relationship between the two requirements, with the requirement and the requirement that are preceding this requirement. Getting in a more an abstraction level up, this is very important, because also the conveners of the standards ask the question very similar to the one you asked, and of course our tool are not addressing this. Our tool addresses the way a single be understood, but about the organization, the hierarchy. This is another problem. We have tried to think of it, but still at the very beginning. And I know there are researchers more advanced than ours on this. We hope to get information, to get data from those environments, but it's not our case so far. sorry, but this is out of our reach for now.
Yes, thank you. And my second question related to expert team who involved into preliminary analysis and preparation of data sets and so on for your tools and for your technique. What is your opinion about weights of industry experts and the more academician expert to assess quality characteristics? I mean, for practical specialists, maybe more important to have strongly verified requirements. I mean, more quantitative requirements. One of the best standards which I know is the standards IEEE 15408 related to security guarantee. What your opinion concerning balancing of experts understanding when we form requirements of new standards? Thank you.
Oh, thank you for the question. I don't know how it's close to what some people I know in my institute and among the conveners of stand. The question is very, again, your question is very similar to a convener of a future IEC standard told me just a couple of weeks ago. And he said, we have this problems, and we would like to have more expertise before issuing the next version of each standard draft. And he said, I think a team of experts should be made, but what I will need for instance, my project to extend the reach of and also the environment of the analysis is a team composed of necessary one data scientist. I've used the data. I'm in machine learning, but I'm not a data scientist. I'm so expert of standards, but no, I'm not a data scientist. I need and also I need a programmer, with in this case, able to process it text. I use personally some Python stuff, Python libraries, because they are providing many way to analyze and to process text. So I need programming, and so a data scientist is important. A programmer, I need a standard specialist, and I need or security and or safety expert in the team. The team is necessary to devise a method and possibly tools to be used. But a method may come shortly. Making a tool is another story. Making a tool is quite a job, and a finance project is needed. But trying to devise a method which is going to be use existing tools can be done. For instance, to address your problem you said before, there are tools performing clustering. When you perform clustering, you can also try to find a hierarchy in those in the result of clustering action. And this was not my opinion, but I share this opinion that can be done. So we do not have anything ready by now. we need to put together some competencies, you said, as you asked, and I am proposing. And but it's going to be interesting because I have to meet again a couple of convener who will try to organize a team which is going to work and to proceed in this research line of standard qualities, which is not interesting for many people, but for convener it's interesting.
Thank you.
Thank you.
Okay, one more question. The question about possibility of AI. We know that now AI writes music, writes poems, and so on. What is your opinion as expert in area standards in engineering? Can AI develop standards?
Sorry, can AI?
Artificial intelligence can artificial intelligence write or develop standards?
Well, I think so, but I think it did a very long research line to do that and attempts. But I am positive on this. I am positive because in analyze a very large, you can find patterns to be used to also to make a standard. But any project I'm seeing is. I see any project I can figure out would, in my opinion, would have a person in the loop, at least a person in the loop, assisting and trying to oh, this is good, this is not good, because AI doing completely this. But I'm not an AI expert, so I just try to use some results of AI work to do my and to progress in my research, current research. Thank you so much.
Thank you. Thank you very much, Mario. Any questions? Other? No, I don't see. Thank you, okay. Mario, one more for your very interesting talk, very interesting presentation. Hope for our future cooperation. And now Sorry. Do you hear me?
Yes.
Yes, my internet connection is not stable. Okay, thank you very much. And
Okay, sure. Thank you.
Thank you. Now our next presentation. It's my pleasure to invite for this presentation our long-time industrial partners. Dear colleagues, do you hear me?
Yes, yeah.
Thank you. It's Infineon, a company Infineon. Our today presenters, Dr. Alexander Karpin, Dr. company which had quarters in Germany. Alexander has 20 years of industry and academic experience in algorithm, embedded system solution, and so on. His research interests include human-machine interaction and interfaces, biometrics, sensors, IoT, wireless connectivity, artificial intelligence for embedded systems. Alexander has 68 United States patents. And Dr. Orest Akimishin received PhD in the same university, Lviv Polytechnical National University. He is currently a principal system engineer at Infineon Technologies. Orest has 15 years of industry experience in embedded system solution, hardware, software co-design, and firmware development. His research interests include IoT, firmware development methodology, security, and embedded solution. It's my pleasure to invite Alexander and Orest for your presentation. Thank you for your contribution for this conference. Welcome.
Okay, thank you, Vyacheslava. It's a pleasure for us to be here and present our company. I'm sharing our slides. Okay.
Yes, we see your presentation. Maybe full screen you can make.
I just made full screen. Should
Okay.
be okay. Our topic today is connected, secure, smart sensors. And from the title of presentation, you can see that we will talk briefly about some introduction and the state-of-the-art technology in sensors, wireless connectivity, smart system in embedded security. Before we will talk and move on to the technical stuff, a few words about us. So we represent Infineon Technology Company, German-based company, multinational, and that have office in Lviv, Ukraine. And key topics for the company is decarbonization. It's actually like our social responsibility also to save CO2, energy efficiency, and sustainability. And the second big topic is digitalization. It's to improve our productivity, comfort, create new use cases, and make our life better and easier. So from financial standpoint, you can see that company is rapidly growing. Maybe the last 5 years, it's grew up by 2x. And in the company, we have different divisions: one automotive, industrial power control, power sensor system, and connected secure systems. And Infineon, just to add some scale, Infineon is a global player in semiconductors, at clearly #1 in power semiconductors in the world, and #4 in overall microcontroller market. Okay, so let's today we would like to talk more about smart home solutions. And it's a nice picture that represent all different smart devices that we should have in our home, but not sure if actually today we have something like that. And we will present how industry address this problem. You can see. Okay. Do you see? You see still first slide, yeah? Once more, I will share. Sorry. Once more. Okay. Can you see slides?
Yes, yes. Absolutely okay.
Okay. Have you seen this third slide or fourth? Or it was?
Yes. All okay.
Okay. So I'm not sure if I go to presentation mode. Let's know. Okay, so we will present smart home solution and how industry address this problem today, and how we believe and why we believe that in the near future we will have revolution in our smart home systems. So in general, you can see that if we talk about smart home or general IoT devices, it can be represented by this simple block diagram, despite is it which kind of device it is. On the left side, you can see it's like different kind of sensors. In the right, it's like response or power part. Also, we need to have connectivity, microcontroller to implement smart functionality, and very important part also to have a trust to the device, it's security. Let's talk about sensors, how we represent and have from the sensor standpoint. The first, if any electrical engineer consider sensors, it's usually sensor, it's like capacitance, inductive, resistance, current, voltage on the output. It's some device that have these characteristics. And for example, few examples. If you talk about capacitive sensor, it could be capacitive button, trackpad, liquid level, proximity sensors. Or if we talk about sensors that have current on the output, it could be PIR sensor for motion or presence detection, or it could be ambient light sensor to detect day or night, or maybe optical proximity sensor to detect some gestures, and so on. There are a variety of different sensors. And you can imagine all these complexities that engineers to work with all these kind of sensor, having microcontrollers, they need to have special blocks to operate with all of that. So in Infineon, we presented, like if you see programmable system on chip, then we have one block that we called multi-sense converter, that just one block can connect to mostly all these sensors, and having analog bus and allows us to connect to one chip all these kind of sensors. So how many pins do you have on your microcontrollers? So many sensors you can connect and operate. So it's the first, let's say, revolution in all these sensors. The second, that we start considering sensor not just like physical device, but devices that simulate human senses. For example, smart feel, smart eye, smart nose, smart ears. Okay, I will stop sharing for some reason. People saying that they don't see all my slides. Have you seen these slides before? 9, 10, 11? Sorry for that. I'm not sure what's going on.
Yes, we see the slides.
Okay, good. That means that just for one colleague, they can see. I will present not in presentation mode, but in this slide. But it's very important that from sensor standpoint, you can see that.
I'm sorry, just one moment, Alexander.
Yeah.
Now we
Yeah.
can't see your slides.
Can't see now.
Yeah, before it was good. Now nothing.
Okay, but now it's okay. Yeah.
Still no.
No, I can't see it.
Share. I can share desktop, but just can share a window, and for some reason, okay. Now
Yeah,
it should
okay.
be okay. Yeah. Okay. Let's try move on. So the first very important message that or revolution through sensors, that all this complexity of the sensor can be done in one block. So for electrical engineer or system engineer, they can use just one multi-sense converter to connect to all these different variety of sensors. Having analog bus and microcontroller, you can connect all these sensors to the one pin and use sensor fusion, processing, and all this good stuff. The second revolution, we can say that we consider sensors as as human senses, like smart field, smart eyes, nose, smart ears. And let's see some example. For example, smart nose, it's like CO2 concentration sensor. So we developed this sensor, and we put like in our experiments together with a high accuracy reference CO2 meter that cost $1,500 bucks. And we see that it's quite good correlation. Very tiny, low cost, cheap device and very high expensive gives mostly the same accuracy. But the question, why we need to measure this CO2 concentration in our real life? Why we need this smart nose? For example, research indicates that the impact of CO2 on human decision is dramatic. For example, we have today the conference, and I am happy that I am presenting in the morning, but if it's real life conference, and in the end of the day, we see in the meeting the CO2 level usually increased to some level concentration like 2000, but we can see if information utilization, if CO2 level is like about 2000 ppm, we just mostly students or attendees mostly dysfunctional. It's not because it's end of the day, we are tired, but just because of CO2, we create environments that our students, our attendees are mostly dysfunctional. And this is very, very important. And how this and you can ask how we can make this sensor so cheap, so small. But if you see, we are using photoacoustic sensor principle. So we have the simple LED, optical filter, and that's all. And we put our microphones inside the, let's say, box.
Can't hear.
Maybe the problem is with internet.
Can you hear, Oleg?
Yeah, I can hear you.
Maybe problem is internet from Alexander's side.
Yeah. Okay, I am back. It was power supply drop, so sorry. Okay. Next time I will travel. Okay, can you see my screen?
Yes.
Yes.
Yeah.
Yes.
And as I finished, the innovation is very simple. You can see very low cost infrared optical filter, state-of-the-art microphones that we have in any mobile phone. And as a result, molecules of CO2 resonate at some frequency of light that we are controlling by optical filter, and microphone can measure the pressure, and as a result we can see the CO2 concentration. It's very low cost, very small, and as a result we can address lots of different applications in smart home devices. Like we just when apply CO2 sensor for ventilation control, for we can save energy by 30%. It's a huge savings, and also we can improve productivity, comfort, make healthier our life. The second sensor, it's like smart eye, like time of flight technology. From block diagram, you can see it's quite sophisticated circuit. The same, we need to have infrared modulated car light. Next, we need to have lens, pixel of matrix. We need to have some processing, ADC converter, but in the end, we are getting depth and amplitude of signal. And it's quite complicated circuit. By doing special modulation system, we were able to create this sensor very small. You can see for the $250, it's very small and very low cost. And the same, if we apply, I will try once more to go to presentation mode. Okay, if we try to apply this technology for consumer application, it's variety of application. It's like user-facing, world-facing, consumer robotics, augmented virtual reality. We can address a lot of challenges that we are having today. The second smart eye, it's also very sophisticated, like radar technology. So if we talk about radar technology, we can imagine something very big that is used for tracking aircrafts in the military, but also recently we heard about autonomous vehicle and usage of the radar in automotive, but they still, we believe, some kind of expensive. But maybe not know if everyone knows that Infineon like introduced and developed radar technology for consumer. And you can see the same very tiny devices that we have in industry today that can address lots of application for consumer. Like radar technology today, if you put in smart home, can recognize each person in the room. And you can imagine which devices could be created, like occupancy-based hinted ventilation device on-off, directional audio effects on individuals. But our sensor is so sophisticated that they can recognize and monitor sleep signal also, and monitor the quality of sleep, and also can recognize vital and do vital sensing, like for the elderly, very important, or for the fitness. And okay, we have all this sophisticated sensor. Is it enough to create like smart home devices? That's no. And when all these companies today start talking about smart home devices, that the next level, they should be connected. And how they can pick which physical protocols they should use. Is it Wi-Fi, Bluetooth, maybe G5, LoRa? All this very complicated. The second level complexity, they need to develop their own protocols, next software, and you can imagine it's already the team of 500 people and more. And if small startups is willing to create some device or anything, it's mostly impossible. And this prevent this growing of smart home devices, maybe for all these 10 years that we heard recently about this revolution and IoT and something. But just 2 months ago, it was released Matter standard. So what is about? So it's several years ago, the companies, very big companies, including Infineon Technology, 280 plus companies and many individuals came together and created Connectivity Standards Alliance to address IoT needs for smart devices. And actually, it's very simple idea. They created like protocols that all devices should communicate through IP protocol, very well known, and they created open source libraries for all devices to communicate with each other. So despite what you do, for example, just startup company or small company decided to create smart light, they don't need to create all this software ecosystem, and as a result, they were not competitive with big manufacturers. But today, consumer can pick any device that is compatible with Matter and be sure that all their ecosystem will operate in smart home devices. And we believe this will be a revolution for the future of in smart home, and this is great example how industry addressed some problem to make let's say our consumer life easier and better. And the third big component today is neural networks or smart operation microcontroller. And just to mention that microcontrollers today also are quite sophisticated, that you can run on the edge some neural networks functionality, and as a result, device become even more useful for the end user. So you can see sophisticated sensors, great wireless communication plus smart operation. This is what we consider is IoT, but that's not everything. There is also very important next part that will be presented by Orest, and at this point I hand over to Orest. Orest, please share.
Thanks, Alexander.
Welcome, Orest.
It's the first time for us to be here, so it's a nice.
It's actually first time for the 10 last years I'm presenting or participating in technical and academic conference. Can you see my screen?
Yes, we see it.
Okay, thanks. Maybe I. Okay, maybe not.
Shift F5.
Yeah, I understand, but okay. One moment. Go to my portion of slides. Okay. My presentation will focus on security in IoT devices, and my first slide shows that with all the good stuff described by my colleague Alexander, as the number of connected IoT devices is projected to triple. It's projected to grow from about 13 billions in 2022 to about like 30 billions in 2030. And with all that great opportunity and the benefits that we received due to IoT, also great risk comes since the surface of possible attacks increase also with the number of connected devices. And according to the research available on the internet, so why security is important, right? And security in IoT is a growing concern, and reports show that about 1.5 billion attacks on IoT devices in
Orest, are you showing 24 slide? I still see the title. Oh.
Yes, I'm showing. So some.
Can everyone see the slide 24?
No, I think we better stick to the screen
presentation. Yeah. Maybe.
Okay.
Yeah.
You see now?
Oh, now it's good. Yeah. Now it's good.
Okay. Yeah. So a report shows that in the first half of 2021 there were 1.5 billion attacks on IoT devices, and the main reason for these attacks is lack of security. Also, according to cybersecurity ventures, they project that a cost of the cybercrime will be like $8 trillion US in 2023. And if just we take this 8 trillions and try to put it in a slower lower time frames, so it's like 255,000 like in a second. That's like a huge amount of losses. And also I like the setup made by Brian Krebs, that if you put on the internet, if what you put on the internet has value, someone will invest time and effort to steal it, right? So it's like really important to protect data. It's really important that data should be confidential and important to protect assets in this IoT world. And when sensor is connected to the internet, so it's like exposed to the external world, and an attacker or hacker can hack it and get information out of it. And the next question is, so if all this is happening, why is it happening? Why we do not protect our data? Why do not we create like secure devices? And maybe the answer is in the next slide. Like perceptions of a technical specialist, it actually differs from reality. And according to PSI security study in 2021, like 3 in 5 tech decision makers believe that their organization like have a good security level. But in reality, only half of the persons that believe that they have adequate security, only half of them perform threat analysis. That actually shows that the perception doesn't meet reality. On the next slide, there is statistic. Okay, if a hack or vulnerability in device causes financial losses, there always is someone that is responsible for these losses, right? And according to the study, 89% of respondents believe that the responsibility is for the chip vendor, device manufacturer, and software or operating system provider. So it's like a huge amount of respondents believe that the problem is actually in hardware, in device, and that's the reason why big companies such as Infineon and other are interested in security. So we need like to protect our devices and our designs. And the companies are interested in deploying the security into manufacturing. And if you take a look at that, it can be divided in three main areas. The first thing is threat modeling, and it's like in simple words, it's if you don't know what you're protected against, how do you know how much security you need? So depending on the devices and their functionality, there are different security levels and different security requirements to those devices, and that needs to be clearly analyzed before we even start designing this device to provide right security level. As a second item, software security is not enough today. And software security need to be accompanied by hardware security mechanism. And the third item is that we need education and we need technical literacy. And so people should be well educated, and there should be awareness about security threats and how to protect against security vulnerabilities. First item is threat modeling in order to mitigate risk. And this diagram presents secure design process. And secure design process always start from identifying all possible threats to a system. And once all the threats are identified, the next step is to identify countermeasures for each of the threat, and then implement countermeasures in secure development environment. And we also have to appropriately secure manufacturing and supply chain. And after all this is done, the last step is to independent evaluation of security. So like that's a third-party companies that provide certification and assign to device some certification level, for example, PSI 1, PSI 2, or common criteria. These two are like the main in the industry. When we perform the threat analysis, we want to answer the following questions. So what are your most valuable assets? By asset, it's like it could be some piece of information, some data stored on a device that has value. What are potential threats to your device? So how can the device be attacked? The next is what types of attacks do you need to protect against? How severe are the threats? What countermeasures could you implement? What your security requirements, and how does your device meet your security requirements? So these are all questions that needs to be answered during threat modeling on the early design stage. The next item is that software, it's not enough to have security device. We need to have built-in security should be built in hardware. And today the security defenses are, so we need strong device identities. That means when device is connected to cloud, it can be identified and like unauthorized devices can connect, or unauthorized devices cannot pretend like to be authorized ones. So this is something that is built really in hardware. Then we have to support like secure authentication, secure communication, secure software firmware update. If a bug is found in firmware and we need to update to the next version of firmware to fix the bug, so this update process should be secure. Otherwise, someone may pretend and hijack and insert their own software and get access to the assets stored on device, or get access to the system. The crypto key establishment, boot process protection, and we will focus on that in recent slides and in next slides. And crypto flaws, platform integrity verification, stored data protection, lifecycle management. By lifecycle management, it means like during manufacturing devices in a manufacturing lifecycle, and for example, like debug ports are open, so we can connect the device to debugger and debug our code and program assets to this device. But when the device is shipped, it transitions to production lifecycle, and that lifecycle states like whether or not the debug port is open. It is controlled by customer policy. If customer wanted to be opened, so it can be opened by. If customer wanted to be closed, that's just configurable. One of the most important security measures, security protection mechanism in hardware is root of trust, or it's usually abbreviated to ROT. And root of trust is a piece of processor where the secure boot starts, and this portion of processor is protected from outside, from non-secure environment, which usually customer application run. And on this diagram, it represents our dual-core architecture. So we can see it has two cores, Cortex M0 Plus and Cortex M4. And Cortex M0 Plus, it serves like root of trust. When the device starts booting, it boots from Cortex-M0, and Cortex-M0 authenticates the next image that is started on M4. So basically, each image that started after root of trust needs to be identified. And root of trust, of course, it's after that, it's not identified by anything, because it's like first image that starts. And for that reason, this code, it should be placed in either in a ROM, so it can be modified, it's immutable, or in protected flash that also cannot be changed after manufacturing. The next slides present some what is beyond the cryptography for secure boot. So we have a firmware image, and we calculate hash from this firmware image using, for example, like SHA-256. So the result of this operation is fixed with hash digest, and then we sign or encrypt this hash digest with a private key and get image signature. All this encryption process should be performed in secure environment, and usually hardware security module is used for that purpose. Hardware security module is used to generate a pair of keys. Like that's this process uses asymmetric cryptography, and we need a private and a public keys. And private keys is securely stored in hardware security module. It's not exposed outside of HSM. But public key is exposed, and during manufacturing, the public key is injected to the device. This is shown on the next slide, which is verifying digital signature. So the firmware, along with the digital signatures that generated during the previous step in HSM, the hash of the image is calculated on device, and then this hash digest, the resulted hash digest is compared with the hash digest generated during signature verification process. And for signature verification, the public key is used. And the public key, the only requirements here, so public key can be exposed to anyone. Anyone can know public key. But the important requirement here is that the public key has to be stored with integrity protection. So an attacker should not be able to replace public key with his public key on the device. If that is possible, an attacker can sign the image with his private key and upload this image to the device if attacker can change public key on the device. So public key typically is stored in ROM or in one-time programmable memory. One-time programmable memory is a type of memory when each bit of the information can only be changed from 0 to 1, and once the bit was changed from 0 to 1, it cannot be changed back to 0. So this is works like a security storage for important information and for public keys on device. The problem associated with this approach is that the code that verifies the image, it should be built in ROM. If it should be built in ROM, there should be no bugs in it, right? Because it cannot be easily changed. It can be easily fixed. To solve this problem, the bootloaders are usually divided into several stages, and this is shown on the next slide. Next slide shows that the bootloader is divided into 2 stages. This first stage bootloader and first stage bootloader is stored is immutable. It's typically stored in ROM. It can be changed after device leaves the factory. And typically ACV is integrated circuit vendor, manufacturer, chip manufacturer, and RAM is original equipment. Manufacturer is usually represents the parties that produce devices using chips. And customers final provides a final application. And so what we see on this diagram is that the first stage boot is immutable, it's stored in ROM, and its functionality is very simple. It just can authenticate the next stage of bootloader. And the next stage of bootloader, it's stored in it's updatable, it's stored in internal flash, and it can be updated anytime it's needed. But the update has to be secure. Before programming new image on device, its identity, it's verified using asymmetric cryptography. So its digital signature is checked before the programming. And customer application can be stored even in external flash, and its customer application is verified using this second stage bootloader, which is much more sophisticated than the first stage bootloader. So this is referred as chain of trust. And the last step, last but not least, is education and technical literacy. And to achieve this goal, there is different materials available on the internet. So on that includes like a security specification, reference implementation, certified API, for example, PSI certified API provided by ARM. They define it like a standardized interface that can be used by different vendors, but it will be compatible irrespective who is the chip manufacturer. Security trainings are available, and also security certification. I mentioned it before, like to achieve some level of security certification like PSI level 2 or PSI level 3 or common criteria level 4. It's very high level of security. And our company provide solution for each size and for each size and budget. And our devices are certified to different level of security. So when we go to production, we can like select proper device and have appropriate security level. Thank you. That's all that I have.
Thank you very much, Alexander and Oris, for your presentation. Now we have time for discussion. Dear colleagues, welcome for questions and answers.
Alexander is here. Thank you for your presentation, Alexander and Orest. I'm using Infineon in a lot of projects. So first of all, it's great to use your sensors. Apparently, CO2 sensor, the PS family has been really in industrial revolution, I must admit, because we have been working in HVAC with classical sensors, and that was really good. My question is, though, is that you can see that, the chip shortage is really kicking a lot of product life cycles now. And what I can see is happening is that due to, very nice chip vendors, facilities, like, for instance, you shown with the security, vendors, actually, or the product owners, they want to step away from that. Better processor that has all the nice bells and whistles, and then it's not available or has 72 weeks lead time, to have simpler processor, but then, push more functionality into software, because they can replace the processor and the product, they can continue selling. How do you see this development in comparison to this very nice all embedded, solutions where, first of all, you have problems with supply. Secondly, you might have problems with IP as well, because, if it's super smart sensor, then IP belongs to Infineon. If something doesn't work, then what to do?
Okay, thank you, Alexander, for good words and the question. So we mostly on development side, but I can say that from chip shortage, Infineon is in good shape. They have their own factories in different countries, and now just recently was introduced new factory in Dresden for 5 billion. They are opening new factory, so it's like addressing a chip shortage. And from IP standpoint, it's always let's say the problem, and that's why we are working with universities, with different companies, as innovation is very important, so continuous innovation. So you can see from our side, it's just the only method to protect ourselves on the market. And from Infineon, you can see that, yeah.
Okay, thank you. The second super short question: have you got any kind of PSOC, or maybe the specific parts of the PSOC 6 family support functional safety?
Functional safety, just maybe some blocks, for example, CapSense. Then for functional safety, we are providing all documents, assessment of the quality, so something like that. But it's not like freely available. You need to contact with appropriate responsible people. Yeah.
Okay, thank you very much.
Okay, so
Thank you. Other questions, colleagues? I have one question for Alexander and one for Orest. Alexander, last week at the lecture with my students, we analyzed the case with Tesla accident when in China, when driverless car destroyed a few buildings, killed a few people, and problem with AI-based system on-board system. My question is the following: can we solve such problem or decrease risks of AI-related by increasing of number of different sensors on the car board? I mean, we can push, we can locate more sensors on the car, and by processing of information from such sensor, decrease safety-related risks.
It's very,
it's not my suggestion, it's just my thinking. More direct, without any additional analysis. Please.
It's very, very important and very complex maybe question. We are calling this sensor fusion. And like sensor fusion, when you can combine knowledge of different sensors to make some decision. And it's hard to say. So I will be glad to work with you on this area, like how we can improve system reliability, decision making based on sensor fusion. So it's hard to answer. Yeah. So most are trying to put more sensor, but you know that more sensors, it's more errors also and introduced, and it's extremely complex. Yeah.
Yes. Thank you. And my question to Orest about more security issues. It was very interesting hear you concerning security of hardware. Yes, because usually this part is not very popular, but very important as I think. My question is the following: what about your experience in application penetration testing for testing and for detecting of hardware hardware and maybe platform vulnerabilities. Yesterday we discussed this problem for robotics system, and it was very close to your presentation. Hence, in your practice, do you apply pen testing, and which features in this area? Is it possible completely to test vulnerabilities? Thank you.
Thanks for the question. That's a really important and very interesting question. Yes, but the answer is yes. We perform penetration testing.
Yes,
and, yes. Yeah, for sure. We do that, and we have like a separate department, even separate group that is responsible for penetration testing, and we have a very sophisticated equipment to do this penetration testing. For example, laser or Röntgen beam, and different kind of like micro probes that you even can like open a chip package and connect to inside the chip and probe the buses between microprocessor and embedded memory on chip. So Infineon is a very serious player on the market related to security, and so we perform all this testing, and we also certify our chips to correspond to certain security levels.
Yes.
Sure.
Yes, I've been in your company in Lviv. It's was very interesting trips, and I remember your equipment which you used to test such automotive systems. But now I better understand features of penetration testing for hardware, because equipment can be used to test as usually, yes, but concerning vulnerabilities, there are some specific features and maybe some restrictions to directly test hardware vulnerabilities. And maybe your comment additionally for this.
Yes, and nowadays hardware attacks on chips are very common, and they become cheaper and available to almost everyone. And the time that is required to hack a device is integral parts of any certification. If your device can be hacked, for example, in one day using standard equipment, so there is no security. If your device can be hacked, for example, in 1 month using standard equipment, no security. If your device can be hacked in 1 year, but it's required like very special equipment that cost maybe like $1 million or like several hundreds of dollars, so then there is security in this device.
Thank you very much. Any other questions? I have good possibility for continuing of our joint research and development.
Can I have a question, Slava?
Professor Nikos Bardis, welcome.
Thank you. Very nice, very interesting presentation, very useful also for all of us. I like to ask you, I saw that you make a verification and authentication through HACCP actions and public key of asymmetric algorithms. This is between the servers and the sensors, or between the sensors also? So by the exchanges of information between sensors, also you make this authentication?
Yeah, okay. Thanks for this question. Actually, this asymmetric cryptography that I explained, it was for booting the next stage image. It was not related to secure transfer of the information. I think secure transfer information is performed using symmetric cryptography.
and the authentication that I saw in what level of security you use them?
Do you mean
For what? In which communication you make? Between which?
this is
The symmetric, as I saw. In which level you use them?
we use them when we boot the device. When the device boots, we start from the firmware that is programmed in ROM and it's immutable, and the next firmware that is booted on the device is its identity is verified using asymmetric cryptography. So like the next stage of firmware has to be signed with private key, and there is public key on the device which is used to authenticate the firmware.
Oh, very nice. And which algorithm you use, if of course it's not a secret, you use standard RSA or something else like elliptic curves or something else? Because
so
it's a computational process that for such computers.
Yeah, it's used extensive computation process, and we have like dedicated hardware block, IP block, like that this computation performed not on the CPU by software, but by special hardware blocks. And we use both RSA and elliptic curve cryptography. And for RSA, our most recent device used RSA 2045 key lengths, and for elliptic curves we use CDSI 256. For hash function we use SHA-256.
Oh, very nice, very nice. Thank you very much. Thank you very much. Thank you.
Thank you.
Thank you. Thank you. Any other questions?
I just want to add, Alexander is here,
Alexander,
that
yes.
what Orest and Alexander explained, that's more to Professor Nikos, is that it's a protection from classical problem called jailbreak. Push the non-signed firmware, and then processor kind of opens up from RAM and allows you to to get the firmware back from the already flashed product. I think for pin testing generally, what was asking about is it's interesting, and I can see the industry demand on being able to assess products from impersonating data on in-circuit buses, like the small ones, I2C, I2S, whatever, the smaller buses where you do not expect to see. And normally during implementation, it's not common to protect those buses because you want to have maximum throughput. So that is rising need, as I see in the industry in general. Thank you.
Yes, and
Thank you.
this problem, yes, that you mentioned, yes, that's an important problem, and I believe it's addressing in the way that these buses can only be accessed in non-secure environment, and there is a distinct separation between secure and non-secure. And the interface between secure and non-secure, it cannot be through the external buses. It's only very tight, very clear, and very limited interface. When the non-secure environment sends a request for secure environment to provide some kind of service. Yeah, but that was a great comment. Thank you.
Thank you. Okay, let's thank our industrial partners, our colleagues and friends, Alexander and Orest, for very interesting presentation. And we would like to wish you success in your industry business, and we would like to be safe when we put our car home for our cooperation in the future. Thank you very much. And
if you want the partners in Greece, here we are.
Yeah, thank you.
Thank you.
Have a good job. Yeah.
Okay, thank you.
Thank you. Thank you very much.
Thank you.
Okay, dear colleagues, we have finished our 5 plenary session, and now we have 10 minutes for our virtual coffee break. We will start our work online in session 1.5 and 2.5. Please prepare your presentation and welcome all participants for very interesting 2 sessions topics related to cybersecurity, safety engineering, and so on. Thank you so much for your participation in this plenary session. Please, 10 minutes later, we will start.